set your name on the Zoom like this. Also, please add the student ID and the full name. And also, please set your name in English. So also to match the full name in your name in the key elements. Okay, and also please turn on your camera and turn off your mic. Okay, good. Okay, so yeah, let's get started. So in this course, we are going to discuss some topics at the intersection of the machine learning or the deep learning and also the 3D and the geometric data. So today we are going to have some kind of the brief overview about the things that we are going to discuss in this course over the semester. So I'm going to start with the ChatGPT. So I guess everyone knows the ChatGPT, but how many of you are basically using the ChatGPT? Are you using the ChatGPT in your some kind of daily things? Yes or no? You can click the no button or is everyone using the ChatGPT? Yeah, I guess this was kind of really big things this year. So until last year, actually, the most people did not expect that we will be really able to see such kind of a chatbot actually that passes the Turing test and that like the chat like the humans. And now the ChatGPT became a kind of a tool that literally everyone basically knows.
이거 카메라 안 켜도 돼?
Yeah, please turn off your mic. Yeah, and also that most people use this kind of the GPT tools in their daily lives, and I think this is really amazing kind of the advance of the AI, the technology, and we are I think seeing the one of the most the important ones in the history of the AI, or perhaps in the history of the human beings. And after the ChatGPT, now we are also seeing some kind of the AI models that can not only generate the text like the humans, but also can produce some kind of the surreal images with the very high quality like this. So all of these basically the images are basically the machine generated images by the Midjourney. That's also everyone know the Midjourney is. Are you also using the Midjourney in some kind of cases? Is there anyone who tried to use the Midjourney before? This kind of like image generation the tools. Yes? No? Yeah. I guess some of you might be already using this kind of some image generation tools like the Stable Diffusion, DALL-E, and the Midjourney. So in terms of the quality of the images, like this kind of like the produced images, I think there's obviously basically nothing we can do more in terms of the quality. The images are already very realistic, but there might be still some issues in terms of like how we can control such kind of the image generated models, and that's why people are saying that basically the prompt engineer might be kind of the new job that can basically replace the human designers and the artists and the photographers. So image models are basically at the level of basically threatening the realm of the arts. So what would be the next step? So now we also have the AI models that can produce the text and the codes and the images. Then the next step might be also kind of designing models for the videos. And for the videos, still there is kind of a long way to go. The best technique that we can see for now is this kind of a technique that can produce very short the animation for less than like 10 seconds with some kind of the small changes in the video. But many people are expecting that we will soon see a kind of the much better the quality of the video generated models that can create, for example, like some kind of the TikTok videos or some kind of YouTube shorts. So we might be able to see a kind of the AI YouTuber in the near future. So now what we can see is that basically we can really say that now is a kind of the era of the generative models. We know the generative models for the text, code, and the images, and there are even some kind of the cases that these are basically being used in some kind of the commercial services. And the next would be basically some other things like the basically video, the games, and the 3D. And according to this kind of sequoia capital in this the diagram, we will be basically able to see some kind of the second version of the 3D generated models in a couple of the years in 2025, and also something like some kind of AI, the Roblox, basically some kind of the personalized video game and some movies in the 2013. And as you can see, seeing the second version of the 3D generated models actually means that there is already the kind of the first version of the 3D generated models. So let me briefly show the state of the art of these 3D generative models. So this is basically the state of the art for now for these 3D generative models. If you are a graduate student working on this field, doing some research in this field, you would know this work, which is called the prolific dreamer. And how many of you have seen this kind of the output of these 3D generative models? Is everyone familiar with this kind of some 3D generation techniques? Yeah, I'm not sure. Yeah, so these are basically all some 3D outputs that are basically produced by some kind of the AI models. So I don't know what you think about the quality of this. Like some of you might think that still the quality is not good, and obviously this is not a quality that can be really used in some kind of some commercial products in some kind of the real games or some kind of the AR, the VR, the applications. But actually, these 3D models have been a kind of a long-standing problem in the AI since the GAN basically appeared in the 2013, and the quality we could see so far for this 3D generative model was really poor. So it was really hard to imagine such kind of the high quality even until a couple of years ago. So compared with that, this is really kind of the huge the advance. Now this 3D general model is one of the very hot topics in the AI research that the many people are really working on. So we will be able to see much better the qualities, sometime in the next year. So where can you use this kind of 3D generated outputs? Well, there are lots of the applications for that. But also one thing is that as this 3D is also coming to our daily lives, the many people are also expecting that, for example, like Apple Vision Pro and the other some kind of the head-mounted displays will change the way that we work with a computer while we basically interact with some kind of the real and the virtual scenes and the objects. And also many of you also know the Roblox, which is kind of the virtual platform where the users make their own 3D contents and also hang out with the other people in there. And for these kind of applications, AI models that can automatically generate some kind of 3D assets would be very useful to expand the virtual world with some much more the variety of the 3D contents. And here's a kind of demo of the 3D asset generation by the Roblox. And let me play this. Yeah, so obviously the quality of the output, the 3D assets are not very good for now, but when you see basically, how the text and the image and the models have been, advanced so far, I think that the quality of the 3D generation will also be improved very fast. Yeah, so and also for the 3D, actually, we are sorry, let me skip. Yeah, to speak to the 3D generative models. Actually, also the interesting aspect is that if we see how the texts and the image and the models have been improved so far, actually the incredibly quality of the text and the image generated models actually came from the very large scale data set. So some of you know this data set called the Rayon, which is a public data set of the text and the image pairs. And this data set basically includes more than 5.8 billions of the pairs of the text and images. So it's not millions and the billions. So with this kind of the very huge scale kind of the data set, the quality of the text and image generated models have been improved so far. So for the 3D, the question would be whether there is such kind of the very huge scale the data set. Actually, also it turns out that for the 3D, we are also seeing a very fast increase of the scale of the data sets. So until the last year, people are just working on some data set with scale of the tens of the thousands, which is very small. And at the beginning of this year, the scale became about like 1 million. And now there's a data set which has the 10 millions, which is quite big. So you can see that the speed of increasing the scale of the 3D data set is actually quite fast. But still, compared with the scale of the billions, still this is the scale of the 10 millions, not the billions. even the 10 millions will not be a sufficient scale to cover all the possible shapes of the 3D objects at the scene. And also the very interesting fact in the recent the 3D generative models are that these 3D generative models actually developed not in a way to learn from the 3D data set, but actually in a way to produce the 3D by learning from the 2D images. So one of the key technologies in the 3D generation was actually the technique that can basically connect the 2D and the 3D, and basically reconstructing the 3D shape from a given set of the 2D images from the different views. And the core of the recent advances of the 3D reconstruction from the 2D images is the technique that we call the neural rendering that we're also going to discuss in this course. And if we also see the state of the art of this like neural rendering, the technique, so this is the state of the art. So this is actually a result of the 3D reconstruction from a video captured at this deep backyard. And what we are seeing for now is actually not just a video. I mean, this seems just like the video, but the thing is that actually this is a screen where the user is basically navigating, reconstructing scene, like playing a game in the video. So let me replay this. So this is the case. Actually, the user is basically moving around in the reconstruct scene, playing some kind of the games like this. So once you basically reconstruct this 3D the physical scene, you can basically move around there. And also this one is basically working in real time. So this is really like you are copying some real the physical space into some kind of the virtual world and basically hang out there. So this is one of the examples of the neural rendering. And this was a case with the static 3D scene. And this is another example of like reconstructing the 3D humans with the dynamic motions. Yeah, so the output of this 3D reconstruction looks quite realistic. And these are all the cases that basically people are reconstructing all these 3D things by just capturing the video around all the humans. And as you can see, actually, this kind of technique can also be used for some kind of the deep fake kind of the techniques, which also brings up some kind of the ethical consideration. So what we can see in this video is that, let me play this. So you can see the input from the camera on the left-hand side and also the output in the middle. So while the real human is not moving the head, we can see some kind of the video, which is basically changing the pose of the head like this. Yeah. And there might be also some examples of like changing the facial expressions as well. So this kind of technique actually needs some kind of special cares in terms of the, that can basically be used for some kind of the deep fake kind of the things. And also for much more the dynamic scenes like this, we can also control the camera as you want and also edit the video like this. So these are also some kind of examples of the reconstructing 3D scene with some kind of the dynamic objects in the scene and making some kind of the videos like this. Another example of like having a video with the dog while also changing the camera in the scene. And the neural rendering technique is now also being used in some commercial products of the big tech companies, like this kind of the immersive view of the Google Maps. Let me play this video. So now the Google Maps shows this kind of the 3D visualization of the entire city. So this is the result of like reconstructing the entire the London city. And this is kind of reconstruction is also has been done with the neural rendering techniques. So you can check out this kind of the immersive view in the Google Maps now. And this is also a demo from the Google
project. Instead of
looking
at a screen, you're looking at a magic pane of glass. And through that glass, you're seeing another person on the other side.
Say hi, Auntie. Oh my gosh, I love
So you look beautiful.
And then you just start having a conversation, just like you would if you were physically together.
Like, I feel like you're here. This is wild. I can see that curl in your hair. I can.
Yeah, actually, this human on the right-hand side is not the real human, but some kind of reconstructed human. So this is the case of like reconstructing the whole 3D human so that the people can feel like the other person in a kind of a remote place. is physically present next to you and also chatting with you in the real space. So if you can see, actually, this case is kind of the case that
See how your sweater is falling.
showing some kind of the reconstructed these 3D humans.
There are really three breakthroughs coming together here. One is the ability to capture people as they are. The second is the ability to compress that information and send it over existing networks efficiently. And the third is the ability to render that person viewable through a three-dimensional display. So it really feels like you're talking with someone right in front of you.
Yeah, for those kind of the applications, the recent 3D reconstruction, the technique has been used. And such kind of technique is also important for the ARD and the VRD applications with the head-mounted display, because while you are wearing the head-mounted display, people cannot basically see your face or your facial expressions. So the companies like the Meta, like this, basically introduced a technique of like reconstructing the user's face and also capturing all the facial expression in real time, so that the people can basically chat, like seeing each other while basically wearing the display.
You want to have a drone? Here's how you can get the shot with your phone. Yep, you can make this entirely on your phone, and it's easier than it looks. First, have a friend stay perfectly.
Yeah, so the neural rendering technique is also coming to our some kind of daily lives. And now we are also seeing some kind of the AI influencers in some kind of the Instagram or some kind of the SNS for basically making some kind of the TikTok the videos or the YouTube the shorts using this kind of the neural rendering techniques. And this is also the example of like reconstructing the whole scene just using the phone and making the video like this. And this is also kind of interesting, the example that a 3D model designer is now making a 3D model, not using some kind of the modeling tools, but using some kind of by basically the scanning some kind of real physical figure, also using the neural rendering techniques, and also adding the rigging and the motion information. We're making this kind of 3D models, so now we don't need any kind of 3D modeling tools. We just need to basically capture some kind of the real figure and basically add some this kind of the motion information. Yeah, also this is our example of also reconstructing the Nopsugi, the mascot, using the neural rendering techniques. Cool. So actually, when it comes to the 3D, there are also lots of the applications, not only for kind of the generation, but also for some kind of the perception and also the understanding. So when it comes to the perception, one of the most representative example of the 3D perception would be the autonomous driving. And this is the video from the Waymo.
To understand the world around them and get you where you need to go. You're about to see how it all works and what it feels like to ride in our car. As it drives, Waymo uses LiDAR, which sends out millions of laser beams per second to build up a detailed picture of the world all 360 degrees around it. It also uses radar to detect how far away objects are and their speed. And high-resolution cameras detect visual information, like whether a traffic signal is red or green.
Yeah, so you can see that this kind of the autonomous driving the vehicle has the LiDAR sensor at the top of the roof, like this, which can basically measure the depth information, the distance from the vehicle to all the surrounding the objects. And from this kind of depth information, the system is not just checking whether there are some kind of the obstacles or not, but actually the system is basically identifying what the types of the objects are. For example, if there are some kind of the pedestrians, not just the kind of trees or some kind of other objects, then we need to take some kind of the special care with the humans, basically, right? And also using the depth information, the system can also predict for example, the trajectory of basically the movements of the objects like this, in a way that we can basically avoid any kind of collision in the scene. So there are also well-known these kind of challenges from the Waymo with their kind of the open data set. And also having this 3D perception is also very essential in many robotics applications. For example, for this kind of the home robots that need to interact with the objects in the indoor scene. Basically, the robots are basically typically equipped with some kind of 3D sensors, and the sensed 3D information is basically used to understand the 3D environment and also see how to interact with each of the objects. And also the thing is that for many kind of the learning-based methods, it is also very essential to have some kind of the lots of the training data for many kind of deep learning techniques. But for the robotics applications, it is very typically impossible to scale up the data to capture from the all some kind of the possible physical scenes. So what people are doing like this is that basically people are basically making some kind of the synthetic, the 3D, the virtual scenes with some kind of the virtual, the autonomous, the agents in this kind of space in a way that we can basically transfer the knowledge which is learned from this kind of the virtual environment into some kind of the real robots. And this is also another example of the NVIDIA, the Isaac scene in the case of training the robots in some kind of the warehouse.
Multiple lidars to avoid obstacles and blind spots and resolve ambiguities during localization on the map. Every industry has different requirements and platforms for robotics. For example, a quadruped like the Leica Go can walk over uneven terrain or even go up a staircase. Thanks to its modular architecture and our message API, the Isaac SDK is agnostic to the robot platform. This means
yeah, so you can see that the 3D depth information is being used to basically localize the objects and to see how to interact with the objects.
Hello.
Yeah. So also when you also talk about the 3D perception, the ultimate goal would be also to learn how the humans and also the autonomous agents can interact with the 3D environment. And for that, actually, in some of the cases, we need to have some the information more than just like detecting the 3D objects and also identifying the types of the objects, but also some kind of the higher level information, such as kind of the sort of the functionalities or the affordabilities, like how the humans can basically interact with the objects in terms of like what are the parts of the objects where the humans can sit, or what are the handles that human can basically grasp and also pull or they lift up. So for this kind of information, some information about the interactions, we can also utilize some kind of the 3D data, the processing the techniques to learn these kind of things. And not only for the scenes, but also in the level of the object and the human hands, we can also utilize some kind of the 3D data, the processing the techniques to learn this kind of the interaction the information. So you can see that basically all the kind of the techniques about the 3D things are basically done the things that we are basically doing some research in the many kind of the communities, not only in the machine learning, but also in the computer vision and the computer graphics and the robotics. So these are basically kind of the topics that we are going to discuss in this course. So basically, in this course, we are going to discuss some kind of some machine learning techniques that can basically process, analyze, and also synthesize the 3D data. So what we are going to discuss in this course over this semester are several topics. For example, basically for some kind of the other types of the data, for example, like images and the videos and the text, those are basically having some very typical representations, like the 1D sequence or the 2D grid. But for the typical 3D data that we are going to handle in this course, actually there can be some multiple ways to represent all the 3D shapes. For example, using some kind of the point clouds, or using some kind of the voxels or the meshes, or just using some kind of the multi-view images. And actually the thing is that each of these kind of like different representation of the 3D data basically have some kind of the pros and the cons. So we are going to discuss what are the pros and the cons of like different representations of the 3D data, and also how we can convert like one to the other in a way that we can do all kinds of conversion of this kind of the data set. And then we are going to slowly basically start with some kind of the slight, relatively older techniques that can basically process this kind of 3D data, basically taking the 3D data set as kind of input. So using some kind of simple techniques, we are going to see how we can make some kind of the simple deep learning techniques that can basically classify or segment the parts from the 3D object data set. And then we are going to switch gear in terms of like not just making some kind of the neural network, but that can also produce the 3D as the output. So we are going to see what are basically the techniques that can be used to basically reconstruct, basically output some kind of 3D. using the some kind of the neural network, we're also going to see what sort of the representation 3D data basically can be used for the 3D data reconstruction. And then we are also going to move on to the neural rendering techniques and see how the multi-viewed images can be used, and also with the neural network to basically reconstruct the 3D data. And then also we are going to move on to some kind of the 3D generative models and see how this kind of the 3D outputs could be generated, some kind of the neural network, which is even trained not with this 3D supervision, but only just using some kind of the 2D supervision for that. And then we're also going to see how we can basically even combine the different representations of the 3D data in a way to basically make some kind of synergy with different representations, and how this kind of the hybrid representation basically also can improve the quality of the outputs of the 3D generations. And then we are going to switch the gear in terms like seeing how this kind of some 3D data, the processing the techniques can be used for some kind of the object detection and also the segmentation techniques. And also, if the time allows, then we are also going to see how we can basically discover some kind of structure in the 3D. For example, some structures of some part hierarchy or some kind of symmetries. How this can be discovered from the 3D objects will be also kind of the topics that we are going to discuss in this course. Okay, so this is kind of the very brief introduction of this course. And who is this course for? So basically, this course is designed for the people who have some kind of the background in the machine learning and the deep learning. So we are not going to basically discuss some very general ideas for some deep learning kind of techniques, but we will focus on some kind of special topics, which is only for about the 3D machine learning kind of things. So basically, we are assuming that you already have some kind of the background in the machine learning or the deep learning, and also you have some experience within some neural network implementation, because we are also going to have some kind of the programming assignments and also the course project. So I'm also going to explain about the programming assignments and the course project. And this is also the project-oriented course, which means that doing the course project is the most important part in this course. And also we aim for the depth-first learning in this course, which means that we are not going to basically cover all the fundamental kind of some topics on this field, but actually we are going to discuss some more kind of the very advanced topics that were actually introduced in the recent 5 or 6 years. So these are also very new things compared to some kind of things that you could learn some kind of the machine learning or some other computer vision and the graphics courses. And also in this course, there's no exam, and also there's no any kind of the pencil and the paper, the assignments, but there will be some kind of the programming, the assignments, and also the course project as well. And also compare with some other courses. Actually, you might also compare this course with some kind of the other machine learning courses or the computer the graphics and the vision courses. So I would say that the other machine learning and the graphics and the vision courses might be basically covering some kind of the more fundamental the topics in this field. So we are going to discuss some more the specialty topics only for some machine learning for the techniques for the 3D data. And also the thing is that if you are more interested in some kind of some classical ideas in terms of how to basically handle this kind of 3D geometric data, I am also teaching the other course, which is the geometric modeling in the processing course. So the difference between these two courses is that for the other course, for the geometric modeling, the processing, this is not a kind of the machine learning the course, and there will be lots of kind of the pencil and the paper, the homework, and also the exams as well. And in this course, there's no exam and no the pencil and the paper, the homework, and we're going to discuss the very recent and the machine learning related kind of the topics that are about also handling some 3D geometric data. And the grading, we're also going to have the project and the programming, the assignments, and also some kind of the paper, the project review, and also the in-class participation will be also counted in the final grading. So to get a good grade, you basically need to go deep into some specific topic that you choose. You would have some kind of the good programming skills for that. And also we will basically require, you will be basically required to basically actively participate all the lectures. So these are some kind of information for the grading. And at this point, I know that there are actually quite many undergrad and also the graduate students in this course. So if you are a undergraduate students, you might be basically worrying about actually there are some kind of the graduate students in here. So the information that I can give you is that actually if you see the grading the statistics in the past years, you can see that actually the most of the undergraduate students actually could get some even higher the grade than the other the graduate the students. So you may not need to worry about the grading if you see all these kind of statistics. And basically what we are going to do is that we are going to basically follow the grading the criteria that we had in the last year. So you can expect this kind of the average the grades like this. And this is also the tentative schedule. You can also check out all this schedule in our the course webpage. So please also check out some kind of the days that we are not going to have some kind of the classes. There are also lots of kind of the holidays in this semester. Also, the thing is that we are going to have some kind of special days like the guest lecture here, and also the sessions with the project pitches and the poster presentations. So I'm going to also give some more information about these kind of things in the later lectures. For some of you who might be wondering about the difference of this course that also we have done in the previous years, so the major changes that we made in this year is that so there will be no the paper presentation. So until the last year, actually there are some kind of sessions of the paper presentations that are done by the students. Actually, we are not going to have this kind of the paper presentation in this year. Instead of that, actually, we increased the number of the programming the assignments. So previously, we just only had the one programming the assignments, and in this year, we are going to have the 3 programming the assignments, and also we are going to cover some more the kind of the materials, which is mostly focused on the 3D generative models. So those are kind of things. And also, as we announced on the Slack, so all the lectures will be basically online via the Zoom, except for some of the guest lectures. And also all the lectures, including the guest lectures, will be also open to the public. And so feel free to basically, let the others know about this and the lectures. And instead of that, actually, all the office hours will be offline. So this will be kind of the logistics. And also in this course, we're going to have the 2 specialty guest lectures. So on October 11th, right before the midterm week, we're going to have the Niloy Mitra, who is the professor at the University in College London. And we also talk about some kind of his recent work about the 3D generative models. And also Jun Gao is also the research scientist in the NVIDIA research. So he will also give a talk on the November the 20th, and he will also talk about his recent work about the 3D generative models. So these are the information for the guest lectures. And for the more information, you can also check out our the course webpage. So if you go to our the course webpage, you can see that all the information is basically there. So you can also check out all the details there. Cool. Okay, so before we move on to some more details about the course logistics, do you have any questions? This point. So the guest lectures by the millimeter will not be hybrid. So we will try to make it hybrid, but when you see the kind of situation of the classroom, I'm not sure how much that will be basically go smoothly, but we will try to live stream the talk through the Zoom link, but we will see. But basically the guest lecture will be done in the offline in the official classroom, but we will try to live stream the talk to the online. Are the assignments done in the groups, pairs, and alone? For each individual, yeah, the students need to do the assignments, themselves. So the assignments not is kind of some group activities. It's for all the individual, the students, but the course project is for the group. So we're gonna also talk about that. Any other questions? Okay, so actually we are going to get into some more detail of the course logistics. And before that, let me briefly introduce myself. So I am Min Hyuk-sung. I'm also the professor in the School of the Computing at the KAIST. So I started work from here from the 2021. And before that, I was researcher at the Adobe Research. And I am also the alum of the KAIST. So I also did my degree at the KAIST before. So if you want to see me, you can also come to the building N1 and you can find me there. Okay. And also we have lots of the TAs. You can see all the course of the assistants here, and the TAs will help you to do all your basically the programming the assignments, and also our TAs will play the role as the mentor in the course the projects. So you will be able to see our the TAs very soon. And as I said, we're going to have all the lectures on the Zoom. So during all these kind of lectures, please turn on your the camera and turn off your the mic. So you can basically get a penalty if you do not turn on the camera. So please turn on your the camera. And as I also said, please set your name on the Zoom like this. Also, please set your name in English and also match the full name as your name on the KLMS. And actually, also, we're going to use some multiple tools in this lecture. So we're going to use the Zoom for the lectures. And also, we sent the invitation of the Slack. So we're going to also use the Slack for all the kind of the Q&A and the communications, not for the quizzes. So please also check out the Slack. So if you did not receive the Slack, the invitation, we're going to also send you the invitation link quite soon. So please join the Slack as early as possible, because we're going to have all the announcements made in the Slack. And also, we're going to use the grade scope for the programming assignment submission. But for the course project submission, we're going to also use the open review. So I'm going to get into the point of like why we're using the open review for the project. And for the quiz, actually, we're going to have lots of the quizzes during this kind of the lectures. So please answer all the quizzes on the Zoom. So let's try now. So let me ask the question like, what is your motivation for taking this course? So please provide a short answer on the Zoom chat now. Okay, cool. So this is basically what we are going to do over this semester. So I'm going to ask lots of the questions during the lectures, and you will need to basically answer the questions on the Zoom chat. And also all the answers for the questions will be counted for the final grading. So we'll see how it goes. So let me go back to the course logistics. We have the in-class participation and the programming assignments and the projects and the paper and the project review. So in the in-class participation, basically this is the course which is a part of the Education 4.0 the program, which is basically encouraging all these kind of interactions between the instructor and the students. So as I said, you will basically take lots of these short quizzes during the lectures, and each of the lecture may start with some kind of quizzes about the previous lectures. So please be prepared for all the quizzes. Actually, the thing is that all the quizzes that we're going to have in this course will be very easy. And also the thing is that our TA will not check the correctness of your answer. So please feel free to basically post any kind of the answers for that. But actually the answers still should be kind of the reasonable. So which basically means that the answer should be something that is coming from the people who basically at least like understood the questions. So please try to at least like provide some kind of the reason of the answers. And also the goal of the quiz is basically to encourage you in basically participating during the classes, not to evaluate you. So what we are going to do is that our TA will basically randomly pick one of the quizzes during each of the class and also to check you the answers. And some kind of the bonus thing is that we are also going to count some kind of good questions or the answers posted in the Slack. So if you also make some kind of good questions or the answers on the Slack, and we're gonna basically mark these kind of the questions with this kind of the heart emoji, and this will basically make up like one missing the quiz in the lectures. So what we are going to do is that for all the randomly sample the quizzes, basically you will receive the 100% score if you answered the 80% of all the quizzes or the more. Otherwise, your score will be prorated. So what this basically means is that if you had like 20 the quizzes and if you answered 16 out of the 20 quizzes, then you're gonna still get the full credit of the participation in this course. The thing is that if you answered only the 15 the questions out of the 20, then your participation score will be 75%. Actually, which will be basically a big loss. The loss that can actually even affect your final grade. So we strongly encourage you to basically participate all the lectures and answer at least like the 80% of the questions. So these are basically what we are going to do. And also, we are going to have some kind of the programming the assignments. And also for the programming the assignments, the thing is that all the programming the assignments have already been released. So you can also check out all the links that you can now see in the Zoom chat. And you can also go to our course webpage. Then you can also find the link of the programming assignments there. So you can see that there are basically 5 the programming the assignments. And you can also see all the details about the programming the assignments. So please check out the README the file in each of the GitHub repository. All the README of the GitHub repository basically contains all the information for the assignment. So you can see what you need to do for each of the assignment and also what you need to submit for each of the assignment. So please start all the assignment as early as possible. Actually, also the thing is that we are having the 5 the programming the assignments, but the thing is that the last 2 assignments are kind of the optional. So you're not responsible to basically this kind of the 2 the assignments. So we are basically providing this kind of the extra the programming the assignments as kind of the resources that you can try to be more prepared for your course project. But actually, you don't need to do the last 2 assignments. But the first 3 the assignments will be basically counted for the final grading. So please check them out. So you can also check out all the links in our course webpage. So the prerequisite for the programming the assignments is that basically we are assuming that all the students taking this course are basically having some kind of the basic programming skills in the PyTorch. So if you do not have any kind of the background or any kind of experience of the implementing in PyTorch, you might need to basically get some more information on that. We are not providing any kind of the tutorials on the PyTorch, but if you need some kind of some basic information about the PyTorch, you can also search for those things. There are plenty of the resources on the internet. But basically, yeah, so this is basically the assignments that we are assuming that you already have this kind of the background. So So if you are not sure whether you are basically ready to do all the programming the assignments or not, please start the programming the assignments as early as possible so that you can see whether you are basically okay to do all the assignments. So actually, the thing is that our the programming the assignments are basically designed as kind of the barometer to assess whether you are prepared to take this course. Actually, especially if you are prepared to do the course, the project. So if you feel that the programming assignments are too challenging for you, this might mean that this course is not right fit for you. So please check out all the course of the assignments and see whether the assignments are basically okay with you or not. So, and before you get started for each of the course, the programming the assignments, please carefully review each of the README file in the GitHub repository. So you can also find all the information about like what you need to submit for each of the assignment, and submit your solutions on the Gradescope. You can also find the Gradescope link in our Slack workspace. So you can also check out the due dates for each of the assignment. The due date of the first assignment is on the September 17th, and the due date of the second assignment is on the October the 1st, and the due date of the third assignment is the October the 15th. So we are basically having the 2 weeks for each of the assignment, but as the all the assignments are already opened, you can basically start all the assignments as early as possible. That's also the thing. And this is also the big thing, the computing resources. So the thing is that we also basically have some kind of GPUs that we also got from the K-Cloud. The thing is that we did not expect that we're going to have like more than 50 the students in this course. So we only have the 50 GPUs in the K-Cloud. So what we are going to do is that we are going to assign the GPUs that we have in the K-Cloud to the undergrad, the students first, because I guess that many of the graduate students might already have the GPUs in the lab. So what we are going to do is that we are also first going to assign all the GPUs that we are having to the undergrad students. So each of the undergrad the students will get at least like 1 GPU in the K-Cloud. But also for the graduate the students, if you also need some kind of GPU in the K-Cloud, please let us know in our the Slack in the Stack Overflow channel. We're gonna also open a survey for the graduate students. In the case when you also need some kind of GPUs, we are going to try to distribute some of the GPUs for them. But the thing is that since we have some limited number of the GPUs, please try to use the GPUs that you have. And also in the case that when this is your first time of like using the K-Cloud, also please check out the K-Cloud the tutorials on our the course webpage before you start your the programming assignments. So what we expect to do is that you can basically try all this kind of the K-Cloud tutorial in this week if you haven't tried to use this before, and then so that basically you can start to work on your the programming assignments from the next week. So that's basically the plan that what we are going to do. So please check out the K-Cloud tutorials on our the course webpage. So you can find all the links in the course webpage. And this is also another important thing, the AI coding the assistant tool policy. While the official policy for all the AI coding the assistant tool in our departments is that it's basically not allowed to use all these kind of tools. But in this course, you are basically allowed, actually even encouraged to use any kind of the AI decoding assistant tools like the ChatGPT, Copilot, Codex, whatever. So you can use any kind of the AI tools to basically in your implementation, both for the programming assignments and the projects. So feel free to use all these kind of the tools for your programming assignments and the projects. But still, the thing is that it is still strictly prohibited to directly copy any kind of code from the internet from or someone else. So you should not still basically just copy the code from any place in the internet or from the solution of your friends. But you can still use some kind of the AI, some kind of coding the tools. So feel free to use any kind of the AI, the assistant tools, but please do not try to copy any kind of code from any kind of other places on the internet from your friends the code. Any kind of this kind of the plagiarism kind of the cases will be basically resulting in a score of the 0 and also report to the university. Any questions for this point? It is clear? Okay, so let's move on to the most important part. So the most important part for this course will be basically the project. So as I said, project is the most important part of this course, and basically you will basically need to form a team with at most basically 3 people and proceed the project throughout the entire semester. So there will be lots of the details for the course project, and for more details, I guess we don't have time to basically discuss all the things in this single lecture. So please check out the course webpage for all the details about the project. But let me briefly basically go over with some kind of important the deadlines for the project. So what we are going to do is that until the next Friday, not the Friday in this week, but the Friday in the next week, we are going to complete basically the project the team matching. Basically, you are allowed to form a team with at most 3 people in a team. And also the thing is that all the team will be assessed in the same way. Whether how many people you have in the team, all the teams will be assessed in the same way, which means that it's always better to have some more people in the team. It may not be better, but you can also basically consider making the team with all the 3 people, because all the teams will be assessed in the same way. And also the thing is that all the members in a team will also receive the same grade for the project, except for some kind of the exceptional cases. So these are also kind of things for the team matching. Also, what I want to basically recommend you is that if you consider like withdrawing this course at some point, actually if you withdraw this course after the team building the deadline, that means that basically your team is losing 1 person in your team. So please consider this schedule if you can also think about like dropping this course. And what you also need to do for the team matching is that you will need to submit the team information to the open review. You can also check out the open review link in our course webpage and also the Slack as well. So for all the project activities, basically we're going to use the open review. And also you will need to submit all the project pitch videos and the final reports through the open review. So that's the thing. And also the project proposal. So we're gonna also have the project proposal deadline, which will be September 21st. So for each of the team, we'll basically need to submit a single document, including the project proposal, up to 3 pages into the open review. So for the project proposal, also please check out all the details in our course webpage. We are also providing all the details in the course webpage. Several important things is that basically you will need to pick some kind of the topic yourself. You can choose any idea for the project which is related to the machine learning and the 3D. And if you're not sure whether the project idea is really aligned with this course, you can also consult me or our TAs and check whether the idea is really relevant to this course. And also from this year, in this course, what we are going to do is that we are going to ask each of the team to pick a baseline method. So whatever basically the project you do, we are going to ask you to pick the baseline of the project idea, which should be kind of the state-of-the-art work for the problem that you are going to solve. So you first need to find some kind of the existing work which is showing the best performance for the problem that you are going to solve. And also the important thing is that you have the responsibilities to identify the state-of-the-art method for your problems. So our TAs will not gonna find the SOTA method for your problem, but you have the responsibility to identify this kind of the SOTA method. So you can basically consult the TAs to check whether this kind of the method is really the SOTA method, the state-of-the-art method or not. But you cannot ask our TAs to find the state-of-the-art method for your problem. So that's kind of things. And based on this kind of the baseline method that you found, what we are going to do is that you basically need to build all your project code on the top of the baseline method code. So which also means that you also need to find a baseline method that already basically released all the official code for the method. If you also not sure how you can basically find some kind of the project ideas, actually we also provided the paper list of the papers for each of the topic. So you can also check out all these kind of the paper list, and please take a look the link there. You can see that there are tons of the papers for lots of the topics there. So please check out all the kind of the research papers there and start to see what are some kind of the interesting topics for you. So you can also try to find some kind of the baseline method in the list. But also the thing is that you do not need to choose a paper as kind of baseline from the list. So you can also choose any kind of the papers even out of this list of the papers. So that's the thing. And also for the project, we are going to have the 2 project tracks. So this is kind of similar with some kind of the tracks that we had in the previous years. We are slightly changing the direction like this. So we are going to have the 2 tracks. One is basically solving some new problem. So for the cases of like solving the novel problems, you will also need to define the problem definition as well. and also need to explain what's the difference between your problem with some kind of existing problem. And you also need to explain how the new method will be evaluated, which kind of some kind of the benchmark. So these are kind of the track with the novel problem solving. So there's another track which is the performance improvement. So in the case of the performance improvement, this is not the case that you're solving some kind of the new problem, or you're still solving a existing problem, but still like providing some ideas about like basically how you're gonna basically enhance the performance of some kind of existing techniques. So this will be the case that you are basically making some improvement from the baseline method in a way to basically show some kind of the better performance at the end, using some kind of the same evaluation setup with the existing work. So please also check out these kind of 2 tracks in our course webpage, and also think about what would be kind of the right fit for you in terms of the project ideas that you are going to have. And as I said, since we are having some kind of the limited amount of the computing resources, what we are going to do is that we plan to provide either some 2 GPUs with the 24 GB RAM for each team, and or like one 800 GPU in the K-Cloud. So I'm not actually quite sure how much it will be stable to use the A100 in the K-Cloud, but these are basically the resources we will be able to get from the K-Cloud. So we are also going to distribute all these kind of the computing resources after the project proposal. And also, when you think about some kind of the project ideas, it is very important to think about some kind of the project ideas that you can do with this kind of limited amount of the computing resources. Actually, there are some cases that, like, for example, some kind of the generative models, there are also some cases that actually you need like at least like 800 GPUs just train a single network in a week, for example. So this might be really challenging cases. Actually, this is like the case that you cannot do with the given the resources, because we won't be able to basically provide this kind of the many number of the GPUs. So when you basically think about some kind of the project idea while basically checking some papers in the paper list, please check whether basically you can run the baseline method with this kind of the given the limited amount of the resources. So if you need the more resources, actually you can think about basically reducing the scale of the data set, or reducing the scale of the architecture of the neural network, or you can also just think about like switching to some other kind of the baseline the method. So think about this kind of the limited computing resources when you think about some kind of the project ideas. So those are also kind of things. And the timelines. So basically, we also going to have the timelines for the team matching and also the proposal. We're going to also have some kind of the project the mockup, some kind of the deadline, and also the project pitch video the deadline. In our class, right after the midterm, we're going to also have a session that we are watching the project the pitch videos. So that's what we are going to do. And also at the end of this semester, we are also going to have the project the poster session. And also the one important thing is that while we are having all the lectures, the online, the final project the post session will be offline. So that's also one thing that I missed to write here. So you will need to attend all the project the post sessions, and we're going to also have the 2 poster sessions in the week right before the final. So please check out this schedule, and also you will need to attend all the offline the poster sessions at the end of the semester. And also you need to submit all this kind of information with this kind of deadline. Any questions for the projects? Good. Yeah. So lastly, we're going to also have some kind of the paper and the project reviews. Actually, the goal for the paper and the project review is that the thing is that your project will be evaluated, but by not just me or the TAs, but also the other the students as well. So we're going to basically have some kind of the peer evaluation system. Can you look at the presentation from the previous years? You mean the presentations of the project, right? Yeah, so you can also check out the past year the course webpage, the links in our the course webpage, and you can also check out some kind of the project outputs there. We're gonna also basically summarize the project the results of the previous years as well, and also post those things in the course webpage. Yeah. So you can also check out, how we also proceed all this kind of the course project in the last year. Cool. And also, when we coming back to this kind of review system, so basically we're going to have some kind of the peer review system for your project, and all of you will have some responsibility for reading some of the others the reports, and also attending all the poster the presentations, and also submitting your reviews. So actually that's why we're going to use basically the open review system, in a way that you can also submit your project outputs, and also participating, basically reviewing someone else's the project outputs. So for that, what we are going to do is that we are going to basically ask each of the team to make some kind of the quizzes, and then the assigned reviewers will basically need to basically answer all the quizzes before starting the reviewing the project. So that's basically the system that we are going to do have in terms of like having the paper and the project reviews. And one more question: can you attend the post session online in the case we cannot make it in the campus? Well, yeah, yeah. For now, we are not thinking of any kind of having some hybrid version of the post sessions, because that will basically make some more the burden in terms of like preparing all the post sessions. So the plan for now is to basically have some offline the post sessions, but we'll see. Yeah, I guess you will need to at least like attend the post sessions when you need to present your the poster. So what we are also going to do for the 2 post session is that we are going to split all the groups of the teams into the 2 the big groups. So like one, like the teams, like like the group of the teams will present in one day, and then review all the other projects in one day. And in the other way around, in the other way, we are basically switching the role. So if you basically presented in the previous day, then we will basically need to review the other project in the other day. If you also review the other project in the one day, the other session, you also need to present your work in the other session. So that's what we are going to do. So which means that at least you will need to basically present your work in one of the poster sessions. So that's what we are going to do for the poster sessions. So that's all the idea that I'm going to introduce for today. Any other questions about the course logistics and what the topics that we are going to discuss in this class? Any questions? Any questions for the course logistics or some the class? Cool. So if you do not have any questions, so what we are going to do is that today we are going to distribute all the GPUs to the undergraduate students first, and for the graduate students, if you also need some kind of GPUs, we are going to open a survey so that you can also post your name there. It will be basically a first come first served basis. So because we don't have enough number of the GPUs, we won't be able to provide the GPUs for all the students. So that's what we're gonna do. So we're gonna start to distribute all the GPUs, the K-Cloud. And if you do not have any experience with the K-Cloud, please check out the K-Cloud tutorial today so that you can start to do the programming the assignments as early as possible. So that's what we are going to do. Okay, so that's it for today. And the next day we are going to start with discuss the 3D representations. So I will see you next on Wednesday. Okay. Thank you.